Bob started the radiator repair work with a very careful and detailed approach, because this was not a normal car part. It was part of a Bugatti Chiron rebuild, and everything in this project required extreme precision. The radiator itself had been built using Honda Civic cores combined with custom machine fittings designed specifically for the Chiron cooling system. Bob spent days shaping, welding, and testing the radiator to make sure it would handle pressure and temperature correctly. Before anything left his workshop, the radiator went through proper testing, and at that stage, everything looked perfect. There was no sign of leakage, no weakness, and no visible issue. After finishing the repair and confirming the radiator was working, Bob carefully packaged it for transport. He even studied the shape of the fittings and realized that some parts were sticking out more than normal. Because of that, he made a custom cutout in the cardboard box, so those parts would not get pressed or damaged during shipping. This was an extra step that showed he was thinking beyond just building the part. He was also trying to protect it during delivery. After the radiator was packed and shipped, it was expected to arrive in good condition and be installed into the car without any issues. However, when it reached the Miami workshop and was fitted into the system, something unexpected happened. During pressure testing, a coolant leak was discovered. At first, this created confusion because everything had already been tested before shipping. The leak seemed to suggest that something had gone wrong in the fabrication or welding process. Very quickly, people online started reacting, assuming that Bob had made a mistake in the repair work or that he had rushed the job. His name became the center of attention, and many comments started blaming him without knowing the full situation. The leak appeared serious on camera, and because viewers did not see the transport process, they naturally connected the problem to the last visible person who worked on the part. However, what most people did not know at that moment was that the radiator had already passed its initial testing phase in Bob's workshop. This meant the repair itself had actually worked correctly before the part even left his hands. The situation became more complicated when Matt Armstrong stepped in to investigate what had actually happened. Instead of immediately assuming fault, he looked at the radiator closely and examined where the leak was coming from. What he found changed the entire understanding of the situation. The exact location of the leak matched a visible dent on the radiator, which suggested that the damage had occurred after the repair was completed. This shifted the focus away from fabrication and toward transport conditions. It became clear that the radiator had likely been impacted during shipping, which caused physical damage to a fitting that later resulted in the leak. This was not something that could be seen during initial testing, because the damage had not existed at that time. So what looked like a failed repair was actually a successful repair that had been affected later by external force. Once this was understood, the story changed completely from blaming Bob to understanding the real cause of failure. After the radiator leak happened and people started blaming Bob, the situation quickly became bigger than just a technical issue. In the world of YouTube car builds, especially high-level projects like a Bugatti Chiron rebuild, viewers often react instantly when something goes wrong. They do not wait for full explanations or detailed investigation. Instead, they judge based on what they see in that exact moment. In this case, the leak on camera looked serious, and that was enough for many people to form a conclusion. Thousands of comments appeared within a short time, and most of them pointed in the same direction. Bob was blamed for the issue, with people saying he rushed the job or did not test the radiator properly. Some even went further and questioned his entire work quality. This is a common pattern in online discussions where a visible problem automatically gets linked to the last known person who worked on it. The emotional reaction spreads faster than technical understanding. At this point, the real cause of the leak was still unknown to the audience, but assumptions were already being treated like facts in the comment section. This created pressure around the situation, especially because Bob was not just a random builder. He had already been deeply involved in the project, creating custom parts, machining fittings, and solving complex engineering challenges that even factory-level support could not easily provide. So seeing him blamed so quickly felt unfair to some viewers who had followed the full build journey. Meanwhile, Matt Armstrong noticed how fast the narrative was forming online and decided it needed clarification. Instead of letting misinformation continue, he chose to go on the second channel and address what had actually happened behind the scenes. His goal was not to create drama or defend someone emotionally, but to bring the discussion back to facts. This is important in large engineering projects because public perception can easily drift away from reality when only partial information is available. Matt understood that once a false narrative becomes popular online, it becomes much harder to correct later. So he stepped in early while the situation was still developing. What followed was a careful breakdown of evidence from the radiator itself. He examined the physical condition of the part and began connecting the visible damage to the leak location. This shifted the entire direction of the story. Instead of assuming fabrication failure, he started looking at what could have happened after the radiator left the workshop. The investigation was simple but powerful because it relied on physical proof rather than opinion, and that proof began to tell a different story than what the comments were suggesting. When Matt took a closer look at the radiator, the situation started to make much more sense than it did at first glance. Instead of focusing on assumptions in the comment section, he focused only on what could physically be seen on the part itself. The radiator showed a clear dent in a specific area, and this dent was not random or minor. It was located exactly where the coolant leak had appeared during testing. This detail became extremely important because it connected the failure directly to a physical point of impact. In engineering terms, this kind of alignment between damage location and leak point is a strong indicator that the issue did not come from internal fabrication failure, but from external force. Matt explained that before the radiator left Bob's workshop, it had already been tested and was working correctly. That meant the welding, machining, and assembly had all passed inspection at that stage. So the radiator was not leaking when it was shipped. The problem only appeared later, when the part reached the Miami workshop. When Matt looked at the packaging, he noticed signs that supported the idea of transport damage. The box had visible stress points, and the area around the radiator fitting showed signs of impact. One of the key observations was that the radiator fitting, which extended outward from the main core, was exactly the part that had been damaged. This made sense because protruding parts are always more vulnerable during shipping, even if the packaging is carefully designed. The dent appeared to have pushed the fitting inward, which could easily create a crack or weak point in the system. Once coolant pressure was applied during testing, that weak point would naturally turn into a leak. This explained why the radiator failed only after installation rather than during initial testing. It also explained why Bob's original work remained valid, because nothing in the fabrication process had changed after it left his hands. The physical evidence pointed clearly toward a transport-related impact rather than a construction mistake. Matt highlighted this carefully, not to create drama, but to make sure the correct version of events was understood. He showed that the damage was consistent with something happening after shipping, likely during handling or movement of the box. This shifted the entire narrative from blame to explanation. Instead of asking who built it wrong, the more accurate question became, what happened to it after it was built? And that change in question completely redefined the situation. Once it became clear that the radiator leak was caused by physical damage rather than a fabrication mistake, the discussion naturally shifted toward understanding the design of the radiator itself. This was not a simple off-the-shelf part that could be replaced easily. It was a highly custom-built system made specifically for the Bugatti Chiron project. Bob had taken Honda Civic radiator cores and modified them heavily to match the cooling requirements of the Chiron. On top of that base, he added custom-machined aluminum fittings that allowed the radiator to connect properly to the Bugatti's unique hose layout. This combination made the part extremely specialized, but it also introduced complexity that standard radiators do not have. Unlike factory radiators, which are usually designed in a neat rectangular shape with predictable connection points, this custom radiator had fittings that extended outward in different directions. These extensions were necessary for function, but they also created weak points during handling and transport. Even if the radiator was perfectly built, those outward sections were always more exposed to impact. Bob understood this risk during the build process. That is why he did not simply rely on standard packaging. He studied the shape of the radiator carefully and realized that some parts would be more vulnerable than others during shipping. To solve this, he modified the packaging by cutting specific sections in the cardboard box so that the protruding fittings would sit safely without pressure being applied to them. This was a thoughtful solution based on what could be predicted from the radiator's shape. However, transport environments are unpredictable. Boxes are moved, stacked, lifted, and sometimes dropped or hit from angles that cannot always be planned for. In this case, it appears that the impact did not come from the direction Bob had protected against. Instead, the force came from another angle that still managed to transfer pressure into the radiator fitting. This is a very important concept in engineering. Even when protection is designed correctly for known risks, unexpected forces can still cause damage. The failure was not because the idea of protection was wrong, but because no packaging system can fully control every possible real-world condition during shipping. This is why engineers often say that design is not just about building something that works, but also about understanding how it survives outside controlled environments. In this situation, the radiator worked perfectly in testing, but the journey between workshops introduced a condition that the original design could not fully anticipate. When the full situation is understood, it becomes clear that the radiator leak was never a simple case of someone did something wrong. Instead, it was a combination of careful engineering work and an unpredictable real-world event. Bob had already completed the repair work correctly before the radiator left his workshop. It had been tested under pressure, inspected, and confirmed to be functioning as intended. This is an important detail because it separates the quality of the fabrication from what happened later. Once the radiator was shipped, it entered a completely different environment where it was handled by multiple people and moved through transport systems that are not part of the fabrication process. In this phase, the part is no longer under control of the builder, and small accidents or impacts can happen without warning. In this case, the evidence suggested that a physical impact occurred during transit, which created a dent in a critical fitting. That dent later became the exact point where coolant began to leak during testing. This type of failure is very different from a manufacturing defect because it does not originate in the workshop. Instead, it happens after a working part has already left production stage. Matt's explanation helped make this distinction clear to viewers who were quick to assume blame based on what they saw in the moment. He showed that the radiator did not fail because of poor workmanship, but because of external damage that was not visible during initial testing. This is a common issue in engineering projects where complex parts must be transported between locations. Even if everything is done correctly at the source, the journey itself can introduce risks that are difficult to fully eliminate. Bob's role in the project also shows why his involvement was highly valued in the first place. He was not just assembling parts. He was solving problems that required deep technical skill, such as machining custom fittings, working with non-standard materials, and adapting components to fit a vehicle that was never designed to be rebuilt in this way. The radiator issue did not change his overall contribution to the project. Instead, it highlighted how even well-made engineering solutions can be affected by external factors outside the workshop. Understanding this helps shift the focus away from blame and toward a more accurate view of how complex mechanical systems behave in real conditions. In the end, the radiator leak became less of a failure story and more of a clarification moment in the larger Bugatti rebuild journey. What first looked like a serious mistake that could damage someone's reputation turned out to be a misunderstanding caused by missing information. Once the physical evidence was properly examined, it became clear that the radiator had actually been built and tested correctly before shipping. The problem only appeared after the part was exposed to external impact during transport, which created a dent in a sensitive area and eventually led to the coolant leak during pressure testing. After this discovery, the focus of the project shifted back to fixing the actual issue rather than continuing blame discussions. Bob returned to repair the damaged radiator, and this repair was relatively straightforward compared to the complex fabrication work he had already completed earlier in the project. The damaged section could be welded and restored, and once that was done, the system could move forward to final testing. This meant that the leak did not stop the progress of the car. It only delayed the next step slightly. The wider rebuild of the Bugatti Chiron continued as planned, with most major systems already completed, including the engine, gearbox, chassis repairs, and interior installation. In that context, the radiator issue was just one small obstacle near the end of a very long and complicated process. Matt's decision to explain the situation publicly helped correct the misunderstanding early, preventing a false narrative from becoming accepted as truth. It also showed the importance of looking at evidence before assigning blame, especially in projects where many stages are involved and not all of them are visible to the audience. In engineering, the final outcome often depends on a chain of events, and a problem seen at the end is not always caused by the last person who worked on it. This situation clearly demonstrated that idea. What mattered most was not the initial reaction, but the final verified explanation based on physical proof. And in this case, that explanation showed that the radiator leak was not a fabrication failure, but a transport-related damage issue that could be repaired and moved past, allowing the rebuild to continue toward completion. After everything was explained, the situation around the Bugatti radiator leak slowly settled into a clearer understanding. But it also revealed something deeper about how modern online audiences interpret technical failures. In today's world of YouTube rebuild projects, viewers often see only the surface level of events. They watch a moment where something breaks, something leaks, or something fails, and in that instant, they try to build a complete explanation from incomplete information. This is not because people are careless, but because the format of online content encourages fast reactions instead of slow analysis. When the radiator leaked on camera, it created a strong emotional trigger because it represented a visible problem in a highly complex and expensive project. The natural human response is to look for responsibility, and in this case, Bob became the focus simply because he was the last person associated with the part. But once Matt stepped in and showed the physical evidence, the entire situation shifted from assumption to observation. The dent, the location of the leak, and the condition of the packaging all worked together like pieces of a puzzle that changed the final picture. What initially looked like a mistake in craftsmanship became a clear example of how fragile even well-built components can be when exposed to real-world conditions outside controlled environments. This also highlighted the invisible complexity behind engineering work that most viewers never get to see. A radiator is not just a simple metal box. In a custom project like this, it becomes a carefully engineered system where every weld, every fitting, and every angle has a specific purpose. When something like that is moved between locations, even a small impact can have consequences that are not immediately visible. That is why testing, inspection, and careful handling are all part of the process. But even then, they cannot guarantee perfection once external factors come into play. In the end, the story was not about proving someone right or wrong, but about understanding how many different stages exist between building a component and seeing it function inside a car. Bob's work remained consistent with the standard of the project, and Matt's decision to clarify the situation helped prevent a misunderstanding from becoming permanent in the public narrative. The radiator leak itself became less of a failure and more of a reminder that in complex engineering projects, the final visible problem is not always a place where the real cause begins. And as the rebuild moves closer to completion, this moment stands as just one example of how careful observation and evidence-based thinking can completely change the meaning of what initially looks like a setback.